Hi, everyone. I'm Matt Ward. I work with the other Matt and even another Matt at Mux. There's a lot of Matts and there's a lot of Steves, in case you guys didn't know. And we've all kind of bashed together ideas for, to give this talk, blah, blah, blah. I've gone through a few titles, something about the internet and a series of tubes and wires and things that connect them and whatever. Anyway, this is a talk about the internet, networking, and stuff like that. I'm going to start with a couple disclaimers. I don't really do a lot of this stuff every day. I'm going to not talk about a couple things during this talk to intentionally kind of make you guys think about a couple things. Raise your hand if you've heard of net neutrality before. Come on, keep your hands up. Keep your hands up if you know net neutrality. Keep your hands up if you actually know what it means. Yeah, half the hands go down. Okay. So I'm not going to mention that. I'm not going to talk about it. You guys can ask questions about it at the end if you want. I'm not going to mention anything like backbone and a couple other random catchy terms that you've heard before. But anyway, point is, this is the tip of the iceberg. There's a lot of other topics in this area, and please feel free to ask questions about them. Okay, so moving on. Let's talk about the beginning of networking. So in the beginning, you've kind of got your little house. Maybe you've got Wi-Fi in your house. You've got a TV you watch tons of awesome content on. Maybe you've got a dog and some other people that watch that content too. Then you decide that you and your buddy down the road want to exchange a bunch of information. What are you going to do? Well, you're going to run a wire between those two locations and maybe you're going to split the cost because it's your good friend Steve, and Steve's like, yeah, it's cool. I'll help you pay for that. So you split those costs, but someone at the end of the day ends up managing a router or something in their home to kind of make this work. So let's kind of talk about that simple network that exists there. Right? Most of us are familiar with something like this. You guys have probably seen this diagram on some networking software that you have running at home, right? You kind of really understand where the bits are flowing, right? Everything is flowing from that little globe at the top there, which apparently is the internet or something, and it flows through your router or something in your home that then lets you connect via your laptops. So what I'd like to do is kind of talk about the simpler part of the network. So let's cut that down. Let's talk about networking at a lower level. What if you just have this router? What if you just have a couple devices attached to it? What's happening there? Well, this is even too complicated, so let's just make it two machines, right? And let's focus on this relationship between you on one device and another device on the network. We're going to say your friend is Steve up there, and you want to exchange content with Steve. Maybe you guys are running a rendering farm together, and you want to exchange images and results of the stuff that you've rendered, and we'll make that kind of the goal of this discussion. So, okay, actually Steve has better hardware than you because he's into this kind of a thing. And so he's kind of like a box that's more of a network server, right? You think of these server things. Actually, it's all just computers. What am I saying? Okay, anyway. So where do you access that content? You want to access Steve's content that he's just rendered, right? Well, you're I want steve.com. Obviously, that's where this content is, right? So what happens? Well, you start with a thing called DNS. And now, DNS in 60 seconds. Who's excited? All right, cool. So here's my attempt to explain DNS in 60 seconds. DNS is what happens when your computer wants to meet another computer that it doesn't really know yet. And so it's all yo, can you hook me up with steve.com? And then, you kind of ask something of a DNS server that question, and you connect to that DNS server, and you say, okay, hey, DNS server, I want to know about steve.com. How do you know where a DNS server is? Most of the time, that thing is hard-coded into your machine. So a lot of the times, routers have this kind of hard-coded in them. You can kind of set it on your router. You can set it in your network preferences. Sometimes it's a thing 8.8.8.8 you've seen. That's Google's DNS, whatever. So you want to ask, hey, 8.8.8.8, can you hook me up with steve.com? So DNS server's yeah, sure. That's over at 10.0.0.2 or whatever. There's a lot of different forms of questions that you can ask in DNS. This is a simple form of a question that's resolved with what's called an A-name record. A-name records resolve to an absolute IP address where you can access the content. So, okay, you can connect at 10.0.0.2. That's DNS in 52 seconds. Cool. Connections. What was that thing? You just kind of brazed over that whole thing, right? What is that? Hey, connections in 60 seconds. All right, here we go. No, I can't do that. there's no way I can explain to you how connections work in 60 seconds. This is one of these things that takes a lot of understanding, a lot of kind of layering in there, right? So when you're going and you're talking about connecting to a specific IP address, what actually happens? Well, you know, to kind of really understand this relationship, we need a little bit more of a framework. And let's narrow down on what was actually going to happen for that connection. We're going to say that connection was over HTTP. Who here doesn't know what HTTP is? Okay, get out of here. All right, so that's that thing that you type in the address bar. That's all it is, right? Anyway, so HTTP. HTTP is an application for serving files and kind of accessing content, and it's got a lot of fanciness to it that I'm not going to go into, but it's kind of this top layer of what they call the OSI model. The OSI model is the Open Systems Interconnection Model, and traditionally it has 7 layers, and I don't really like that at all, so I kind of like to simplify it and say that like the whole top part is 7. That's the application level where like all the good stuff happens, in my opinion. And then there's a bunch of cool stuff at the bottom lower levels. You know, you'll see these addressed by their numbers in a lot of documents that you'll see online. You know, you'll hear people talk about, oh yeah, we provide a level 4 load balancer. What does that mean? Well, that means that they're balancing traffic at the TCP or UDP level rather than the application level. So if you hear about a level 7 load balancer, that means it understands something about the application. So it understands like HTTP paths. It can pick traffic off based on a path and put it to a different server. That's layer 7 load balancing, right? So this is kind of all stemming from the OSI model. Okay, what? How does that relate back to that original problem that you were talking about? Why do I even care about what you're telling me right now? Well, to understand kind of how this laptop that you had on the right and this kind of thing on the left actually talk, you need to start by saying like, okay, those two things are kind of similar, they're the same thing, but what about that thing in the middle? What is that? Like, how do we even conceptualize that thing? Well, is that a router, a switch, a hub, or a bridge, or what even are these things anyway, right? What kind of hardware do I actually need to put in the middle there to make this connection happen? And how do I decide what to buy, et cetera? 60 seconds. Okay, I can actually do it this time, guys. Have faith in me. All right, so what's a bridge? A bridge repeats traffic from a port that the traffic is coming in on to the other port. It just passes it over. That's all, folks. What's a hub? A hub sends traffic from incoming port to all of the other ports. It basically is really simple, really stupid, kind of broadcasts the data back out to everybody, and they kind of know how to handle it. What's a switch? A switch actually understands this first layer up in the OSI model. It's able to understand frames, which include data about the MAC address that it's destined for. So they can actually understand, oh, this thing that's plugged into this port here belongs to the thing that's plugged in over here on this port because that's where that MAC address is. When you're actually sending data over the network, it needs to be addressed by MAC address at this level, and switches can understand that. This is the level that a router operates at. It actually understands IP addresses and knows where to put that packet, or that datagram rather, based on what that packet actually, or what that datagram actually says. Okay, that took me 70 seconds. I failed. All right, well, that's it. We need a switch, right? Because it's just two machines plugged into each other, simplest thing possible. That's the cheapest option. Yeah, sure. Okay, we got two IP addresses, right? You don't really need to worry about discovery. If that's true, there's a chance that you can run your own kind of things to help associate MAC addresses with this and kind of just pass packets around there. It's probably easier to do it as a router, but whatever you want to do. Chances are that's probably a router, because remember that DNS thing up at the top, right? There's a chance that you're actually talking to another network, and in that case, you're definitely going to need a router, right? And that router is what's going to help you communicate with other services like DNS servers and all of that stuff. So let's go back to the earlier problem that we had. Is like you and Steve just wanted to exchange some information. You ran a wire between your houses, and that's kind of the start of what we call a network, right? So someone's managing that router. You're having a good old time, and then your buddy Dan is all like, yo, let me into this party. Like, give me access to that content. What happens, right? Dan comes into this party, and he buys his own cable, joins up, and is like, hey, Matt, I hear that you've got some content that I can have access to. Can I plug into your router and kind of join in as well? So he plugs in. He's got nothing to share, right? So what ends up happening is you and Steve are kind of freely exchanging data at kind of this like 1-to-1 ratio, right? For every bit that you upload, kind of Steve is pushing one back to you. But Dan kind of just pulls all of this content down, and all they want to do is actually watch all the cool stuff that you and Steve have been building on your little network that you're running together. Remember, it's like this rendering farm, right? Like you got like your GPU stacked computers in the corner, and Steve's got his, and you're like spitting stuff back and forth and sharing, and Dan's just kind of watching all that stuff. Oh, Dan actually runs an apartment building. That's getting bigger, right? So what's happening here? Well, you decide, hey, this is getting expensive for me. I've got all the supply Dan wants. I'm running this router. I'm going to start charging Dan, right? Dan has to give me some money, because in order for me to actually give him reasonable service, I need some money. So come on, Dan, pay up, right? So Dan starts getting some complaints from his tenants during this time, and his tenants are like, yo, this network, I don't know. Do you actually know even what you're doing at all, or what? I can only get like standard quality videos. What happened to that HD thing that you promised me? Well, then you call your buddy Kyle, who happens to live a little bit closer. And Kyle's like your good buddy, right? So you go to Kyle and you're like, hey, Kyle, can I just like shove a router and some servers in the closet in your house and kind of just, run some cables all over the place and help connect to this other place? Don't worry about that part, though. Anyway, so you just kind of take all that money that Dan was giving you, you shove it into Kyle's closet, and you use it to kind of help connect all of Dan's apartment into your network, right? So it's probably because Dan was maybe threatening to go with someone else or whatever, but either way, you kind of justified this investment, right? You understand, okay, I know what I can do that, Dan's happy, Dan's tenants are happy, cool. Uh-oh. Maybe Dan's operating Selma here and just built like 10 more apartments or something, I don't know. Dan built another floor to his apartment, either way, Dan got bigger quick. Now you're hitting another limit, right? You're hitting the limit of what's happening over these two lines, and maybe that's like all of the capacity that you thought that you needed, but no, they're just taking more and more than you actually expected. Well, you just make the lines bigger, right? Just add some more cables or something. Well, it's not that simple, right? There's a lot of things that go into actually making the network larger between two locations. One of the first things that comes up is kind of port problems. So there's a chance that my router before doesn't have enough ports to physically plug a cable into anymore. So I have physically maxed out what that router is capable of. And so now I have to go and buy a new one. I don't only have to buy a new one. If I'm like actually operating network, there's a chance that I don't even know how to do that. I don't know how to configure that router. I don't know how to, there's tons of complexities that come into this. not just to hardware. You have to pay engineers. You have to have people understand like how to configure these things. You need to understand what the thing even is that you're buying and who to contract. There's tons and tons of complexity, right? So at the end of the day, though, you're like, these are just costs. I'm going to explain these costs to my partners. Maybe I'm going to raise my costs to Dan because, man, he's been using more bandwidth than we originally agreed on, or something like that. It all works out. You guys decide, yeah, Dan, I'm going to charge you more money. You're using more data, etc. All good. So we go back to our original problem, right? What happens now when on the other end, this shows up? Well, your buddy Steve found some other friends. And Steve's like, no, I'm not doing this exclusive thing with you, right? I want to get some content working with these other guys. I hear the guy like across the street over there has another machine with even newer GPUs than I had, and so he wants to render his stuff over there. So Steve starts a partnership with some other people. They start making films together, and now, Dan's tenants want access to that stuff, right? Dan's tenants actually want access to all of the stuff that just appeared on the screen here. So what happens? Well, there's basically like a new kind of relationship that is starting to happen and evolve here, but it's resulting in you and Steve creating a much larger network, right? You're gonna need to beef up your connections, kind of make sure that bits are flowing through everywhere, and at the same time, Steve just actually signed a bunch of deals with more people like Dan as well. And so, you and Steve kind of had this original agreement and everything was working great. Steve heard about your cool thing that you were doing with Dan, started doing that. He found some friends. Things just started to get more complicated. And you are like, man, my network is not performing well, so let's make it even more complicated and add another guy, because Dan's apartment building was actually getting really into that other content that you saw before in those top left houses up there. And so we got to call in Johnny. Johnny came in here, and Johnny's like, I provide the best transit on the internet. I provide all the best connections to all of the best people that you haven't even heard of. And so Johnny comes in, you sign a deal with him, and he helps you kind of make those connections to that content that Dan's customers want better. So that's kind of a pretty complex network, right? Like, we're ending up with something that started so simple of just you and a buddy sharing some data and became this giant, like, everybody wants in, right? What happened here? Let's talk a little bit about where the money is flowing really quickly. So you've got money here flowing in every single direction. Everyone's kind of investing in infrastructure in different ways, right? You don't even know, like, is Steve paying for those pink cables, or did those other guys pay for those cables? Who's gonna kind of maintain the cable between you and Steve if it needs to be augmented? This all gets really crazy and really complicated really quickly, right? So to kind of connect this back to what we think about in the real world internet, there's a couple different layers of providers that we think about. So we think about the top level of providers as tier 1 providers. Tier 1 providers are people like AT&T, Verizon, Sprint. You guys have heard of level 3, right? These are the biggest providers on the internet, and they are peering directly with each other for free, mutually splitting costs of maintaining kind of connections between each other. And they all have a full view of the network. So if anybody out there wants to access some piece of the network, you can go through one of these tier 1 providers and get access to it. Then on the other end is tier 3. Tier 3 is more like Dan in this apartment complex, right? Tier 3 is simply just, all you do is you have some bits and you're serving them to end customers, and there's not a lot of kind of pulling back and being like running a data center or anything like that, right? It's just a specific end customer kind of use case where you might call these things traditionally internet service providers for, any house or business or anything like that. in between those two, there's a thing called tier 2. It's kind of a weird concept where a lot of things are really blurry, but the general idea is that these are kind of, they have access to the whole internet, but they might have to go through a tier 1 provider to give it to you. And a lot of the times tier 3 ISPs are paying these people, but they might have like what's called free peering deals with the tier 1 providers. And it kind of ends up being really interesting, especially when you start thinking about who's benefiting these relationships. Why are they signing that deal? What's going on? The cost of these whole things just get really complex, and kind of the way money's flowing is really interesting. It's especially interesting when you think about this is happening all over the world in tons of different currencies, in tons of different places. People are like, you know, doing this in the middle of the desert in Africa all the way through to like downtown Manhattan, right? You can imagine these are totally different problems and probably totally different scenarios with the companies that you end up interacting with at the end of the day. So it's really complicated, right? And like this picture, yeah, it's even more complicated than this in real life, right? Some of this stuff's running underwater. How the heck do you even run internet or cables underwater? I don't know. It gets insane. Well, one thing at the end of the day that's really important is you need to be able to find your way whenever you're sending data from one place to another. So I'm going to introduce a concept called BGP, which helps kind of your data that's flowing through the internet actually find its way. I'm going to explain that in 60 seconds. No. This is another one that's really complicated. There's a lot of things going on here. But let's step back for a second and talk about what is BGP. BGP is kind of this tool that network providers use to help answer the question of how do I route this packet of data? Where does it go? What port does it go out of? What peer of mine does this go to? How do I handle this? So each of these providers are what's called an autonomous system. We give them numbers. You'll hear a lot of people in the networking community talk about ASNs. ASNs are autonomous system numbers. It's how we kind of identify each of them. So each of these kind of numbers that you see on here is my faked ASN, right? And BGP is kind of the thing that's going to help us find our way through this network. Each of these ASNs are assigned an IP address. Well, you might be asking, wait, how the heck do they assign IP addresses? Well, you ask this group called IANA. And IANA is what the Internet Assigned Names Authority. And they're part of ICANN, which is an internet corporation for assigned names and numbers. And ICANN basically was like, hey, I'm going to delegate this to IANA. And IANA has continuously kind of broken this up by region and area. So if you're in the United States, you go to ARIN, which is the American Regional Internet. I should have written that one down. Anyway, if you want to have a BGP party, you got to get an ASN. So here we go. Let's actually talk about the BGP session. What's happening during that, right? So my number became 2 in this network. 2 just happens to be my favorite number. I like it a lot. Okay, so let's pretend there's a BGP session which 2 is peering with some people, and it's like, hey, okay, I want to route some traffic somewhere. It's maybe to 5, right? And so you get all these different paths through the network returned to you during the BGP session. It says, okay, you want to go to 5, you can go through 3, you can go through 6 and 4, or you can go through, there's a bunch of other ways you can get there. I probably didn't even draw them all here, right? Let's make a simpler case, right? Let's just say that we want to go from 2 to 4. And it's kind of 2 really clear ways that you can do that, right? Either through 3 or through 6. Well, that's a tie. Well, how are you going to make that decision? There's a bunch of things built into BGP that help these routers actually make these decisions. Can you reach the thing? You know, at the end of the day, a lot of providers are actually just like saying, hey, I have a preference to go to this one or that one. Sometimes that's based on costs. You know, sometimes they'll know, oh, well, if I'm going to send traffic through this peer of mine, I actually have to pay for that. So I don't want to prefer that. I want to go through this thing that's free, but maybe that's going to degrade quality of the connection. And these internet companies need to make these decisions every single day. How do I send this packet from here to there based on all of the people that I'm connected with? And these are hard decisions to make. BGP kind of helps provide a framework for that. it doesn't just provide a framework externally with peers that they're connected to, it also provides a framework internally where some places like 3 in this map are really complicated. They might actually have routers inside what originally was one router, and they use a thing called IBGP to actually help understand, okay, how do I actually send this packet through my network? IBGP is kind of internal BGP as opposed to eBGP, which is external BGP. So eBGP is kind of used between ASNs and kind of at that like top level, okay, how do I connect this packet through the like all of the providers that I'm connected with? IBGP is I need to understand my network and route traffic around. Other things that people might be using internally include like OSPF, which is just open shortest path first routing within kind of older but still very popular and in use protocol called IGP, which is Interior Gateway Patrol. Other things they might do is use a thing called MPLS, which is just multi-protocol label switching. And a lot of people think about that as like L2.5 networking, where it kind of sits in between like understanding MAC addresses and understanding IP addresses. These level of providers actually can run hardware that creates a whole new layer in the OSI model. And that's another option for how they could be routing traffic here. So let's talk about one last really interesting part about BGP that I think is kind of cool. You can actually decide what you're going to advertise to your peers. So, you know, let's say that like you're Steve over there, and Steve's like, hey man, I have a free deal with you, and that means that you have free access to my content. Anything on my network, you can see. You can have access to that, but I'm not actually going to give you access to the rest of the network. Steve can actually do that via BGP and advertise only routes to his network to me. And that basically limits me when I'm connecting with him to only access content that he's directly connected to. And this helps him reduce costs, kind of helps him understand really well what traffic is coming into my network, what should I be handling with. You might have someone more like 3 in this picture, which is like, hey, okay, here's everything. Here, I got access to all of this stuff, right? So this is not always because it's avoiding congestion or trying to help you pick the best path. This is actually sometimes because, well, I don't want to pay for your traffic. Maybe I have to pay for it if it's not staying on my network, right? So I want to spend one more second kind of digging into this with you. There's a lot more stuff here. There's these things called internet exchange points where these things actually happen. And you know, one of the coolest ways to kind of dig into this is via a bunch of these tools, and I'll make sure that we put these slides up somewhere. Raise your hand if you've run traceroute before. Ooh, look at you guys, networking professionals. Cool. Well, this is a tool on hurricaneelectric.com. Hurricane Electric is a large ISP, and I just ran a simple trace route from our IP to one of the IPs in their data center. And you'll see kind of every single one of these hops that it's going through, that's a router on the network that has advertised itself and said, hey, okay, I'm going to take this packet and I'm going to move it to this other router, right? And so this is kind of a real concrete example of what's happening when you actually say, hey, I want to contact this IP address. And you can say, hey, tell me all of the different routers that this is going through on the way there. And you'll see that even sometimes these companies will actually include their autonomous system numbers right in the routers. There's actually a lot of things that you can see in these, right? You can see in kind of this top one here, right? It says SFO and SJC. I think it's kind of hilarious that everybody in this industry is like all about airport codes. And so if you run trace routes, you'll see airport codes pop up like left and right. I think it's kind of cool. So that ASN that I selected is a company called Monkey Brains. Monkey Brains, I think, is one of our internet providers here in this building. And so we can actually see a bunch of things about them in Hurricane Electric's database that says, you know, how many internet exchanges are they present at? How many like IPv4, IPv6 prefixes are they announcing to the world? How many IP addresses do they actually have, right? You can see, oh, hey, look, they have a BGP peering session. Here's how many people that they're actually talking to. And here's the size of their peers that we roughly think is going on here based on the BGP traffic that they're sending out, right? So BGP also helps us understand a little bit about where's this traffic going, who are people talking to, how does the kind of backbone of the network actually work. So the last thing that I'll show you is a thing called peering DB. So this stuff gets really, really interesting when you start looking at, like I'm gonna type in Hurricane Electric here, which is the company that's providing all of this data. I can click into this and say, okay, tell me something about Hurricane Electric. And there's a bunch of information here about all of the internet exchange points that they're at. So these are actually physical locations, and these are all well-known physical locations, and the size of their links that they have in those physical locations that you can actually request for peering at. And if you go down here, it's like, hey, here's our peering policy. We have an open policy. We're nice and friendly people. And if you want to contact us, yeah, just call that phone number, and you can peer with us too. So a lot of this stuff is pretty open, pretty available, and there's a lot of stuff in there that you can actually look at without having to do anything special at all. So I can have some questions. Thank you. Wow, I can't believe you asked that question. In my opinion, the internet is basically at the IP level. So you talk about IP addresses and kind of that, kind of layer 3 to layer 4 networking. And the World Wide Web is a specific application of the internet to transport different kinds of media, traditionally text, but now we do cool things like videos and stuff. So I look at the World Wide Web as an application that's powered by the internet. As a network operator, you can basically black hole IP access. Like you can basically say, hey, everything that was gonna go to this network, just black hole it. Operators can do that. It's traditionally actually done at the DNS level. Most of these providers are doing DNS and provide DNS as a service to their customers. And so you see a lot of people in certain repressive countries changing DNS in order to restrict access to specific websites. It's a lot rarer that we see them take whole entire networks offline. And if they're just modifying DNS, all you have to do is change your DNS server. And I'm sure everyone here has seen kind of the crazy pictures of people in repressive countries literally painting IP addresses on buildings, because that's how bad this stuff gets, right? They need to get access to this content, and the way to do it is change your DNS server. And so people are putting up 8.8.8.8. Use that as your DNS, and it will give you access to the whole web. So hope that answers your question. Suppose like you are using some CDN and you're trying a couple CDNs, and you notice that as you experiment with different CDNs, different ASNs appear at the top of that list. Different ASNs are worse than others. Well, that actually is about how those CDNs have built out their network and how they've actually built out their POPs. If you ever hear the word POP, it just means point of presence. It's not popcorn. Don't get too excited. So what you can do is actually be able to say, okay, I know that maybe CDN A has better peering with these ASNs, and CDN B has better peering with these other ASNs. And maybe in that case, you want to consider a multi-CDN strategy in order to kind of improve your performance across all of the ASNs. And so that's one of the things that we kind of can get out of that data. I'm just going to reply to that with another question. How easy do you think it would be to get every single router in the whole entire world to load new software? I mean, yeah, some of your internal stuff you could. I mean, this is why you've seen companies like Google come out with things like Speedy and alternatives at kind of that layer 4 with like, okay, well, TCP and UDP, but I wanted something in between. And so you are seeing some innovation there recently, but there's a lot of stuff in there that's hard to change because of the scale and complexity and kind of the layer, again, where that has to change. Well, it turns out that we thought the size of the internet was wrong. We thought we knew how big it was going to be, but woo, it is bigger than that. IPv6 is significantly increasing the number of addressable devices at the kind of higher, the IP layer. And so that exists because we're running out of IPv4 address space. That's why IPv6 came out, is to introduce more addresses and make everything actually addressable. This problem has also kind of led to some really interesting things, which is it turns out that IPv4 addresses aren't necessarily associated with a single device anymore. There are certain networking providers that will actually use a single IP address for a ton of customers. So you see people all the time using these things called NATs, network address translations. And they're pieces of hardware or software that can actually translate a single IPv4 address into a number of different IPs underneath it. And so people have been working around this kind of problem of like the IPv4 address space is kind of full, and some of the providers or the assigners of IP addresses are actually like almost giving bounties out for like, hey, give me some IPs back, right? And so, yeah, people are actively trying to give back IPv4s to kind of make that last, because again, changing some of the networking infrastructure is really hard to make it all IPv6 compatible. But IPv6 is happening on kind of newer devices that are coming out, and y'all should use it. There's a lot of different things and tricks that people can do to kind of localize content in the network. We kind of have talked a little bit about CDNs already. So CDNs are one way to kind of move content closer to your users, right? There's a chance that Facebook is operating caches in Australia. I would guess that you are. A lot of like that static content, if you're accessing facebook.com, like to actually load that page, probably just serving a lot of static JavaScript and images and whatnot. That's all probably locally cached and shared across all the users. Next thing is, okay, what about that user data? How does that work? Well, the user data problem of like localizing user data is really interesting, right? Is a lot of large companies do a lot of interesting tricks in their distributed systems to basically try and localize your content to specific servers that are close to you. So they might actually be saying, okay, you're accessing Facebook in Australia. Our DNS resolution is going to receive a request from your IP address, and it's going to be like, hey, Facebook DNS, yo, where should I, go for Facebook? Let's say it's api.facebook.com. I know it's not. Maybe it is. I got a thumbs up. Maybe it is. It is. And so you go to api.facebook.com from your DNS server, and it's like, okay, here's our local Facebook machine that you should talk to. And so chances are it's actually a NetScaler, but we'll get there later. Anyway, you send your traffic to there, and that thing is then routing all of your traffic into that local Facebook data center, whatever it is. Maybe it's an Asia data center. Maybe it's an actual Australia data center. That's like your data center. So chances are that your content is accessible in that data center and primarily in that data center. It might do things like lazy replication out to the United States so that when you're in the United States, you can easily read and access a lot of that data because it's been lazily replicated there. But some operations like editing your profile or something might be slower because they might be like, oh, you're an Australia customer. Your primary data is actually in Australia. So it'll have to route all the way back. And so there's a lot of different tricks that people play at the application layer with figuring out, okay, where should this content actually be stored? Where should it be served from? And sometimes those two things are the same, and sometimes they're even different and lazily replicated. Thanks, everybody.